question here is the equations 3x square minus 5x plus p is equal to 0 and 2x square minus 2x plus q is equal to 0 have one common root. The sum of the other roots of these two equations is. Both of them are quadratic equation. They should ideally have two different roots. Question says that one root is common. So while assuming the roots of these two equations, I'll ensure that I assume one root as a common one. Let's assume alpha and beta are the roots of the first equation and alpha and gamma as the roots of the second equation. Alpha is the one root that is common, beta and gamma are the different roots. The question wants us to find summation of these two uncommon roots. So beta plus gamma UR are question. We have to find beta plus gamma. Let's use summation of roots as the next step, because anyway beta and gamma are the roots and they want us to find the summation of some of the roots, if not all. Summation of roots of quadratic equation is minus b by a. That in the case of first equation should be alpha plus beta minus b by a should be 5 by 3. Quite similarly, alpha plus gamma here should be minus of minus 2 by 2, producing a positive 1 here. Question wanted us to find beta plus gamma. So beta here is 5 by 3 minus alpha and gamma here is 1 minus alpha. Let's add them. So beta plus gamma should be 5 by 3 minus alpha plus 1 minus alpha, producing 8 by 3 minus 2 alpha. We are very close to getting the answer. 8 by 3 is visible in couple of options as well. The only problem here is our answer at present is 8 by 3 minus 2 alpha, whereas all the options have p and q mentioned there. That gives us a hint that we have to convert minus 2 alpha into something that is made of p and q. So how will we do that? Let's use the fact that alpha is the common root of both the equation. Now when alpha is a root of any of the equation, that means you can replace the x in that equation by alpha and the equation will still make sense. So I can rewrite the first equation by replacing x by alpha like this: 3 alpha square minus 5 alpha plus p is equal to 0, and second one 2 alpha square minus 2 alpha plus q is equal to 0. Instead of writing like this, I'll try to make the first term equal. First term was 3 alpha square and 2 alpha square. I recommend we should do double of the first equation and triple of the first equation to make the leading coefficient same. So the first equation now can be rewritten as 6 alpha square minus 10 alpha plus 2p is equal to 0. The second equation 6 alpha square minus 6 alpha plus 3q is equal to 0. We have to subtract one equation from the other one. Minus plus minus. This should produce minus 4 alpha is equal to minus 2p plus 3q. Let's focus on minus 2 alpha. So minus 2 alpha, that is half of it, should be minus p plus 3 by 2q. When we replace the same here, we get the final answer beta plus gamma is equal to 8 by 3 minus p plus 3 by 2 of q. That is your option number 1, the final answer. We have a mixture of coffee and cocoa here. 16% of the first mixture is coffee, cost is 240. There is another mixture, 36% of which is coffee, cost is 320. And then there is a final mixture which has a cost of 376 per kg, and we have to find the share of coffee in this final mixture if the entire mixture is of 10 kg. It's a question of arithmetic and I have two different approaches for this particular question. One approach is going to be pretty standard one and the second approach is going to be shortcut. So I would want you to watch this video till the end. First method. In the first method, I'll assume the cost of both the items coffee and cocoa. Since both of them start with the same letter C, I'll have to do something else, and that is going to be F for coffee, and cocoa can be represented by a C. They were talking about 1 kg, that is 1000 gram, 16% of which should be 160 gram into F plus remaining 840 gram into C is going to be 240. That is your equation number 1. Now the second equation quite similarly should be 360F plus 640C is equal to 640, right? We have to solve both of this equation. Now I am entrusting you with this responsibility. The final answer that you will get after a few seconds should be F is equal to 72 divided by 125. That's a cost of 1 gram of coffee, and C is going to be 22 by 125. These are per gram cost. So I'll multiply both of them by 1000 to get the per kg cost. So that should be 576 rupees per kg and 176 rupees per kg finally. Here's the last step here. We are mixing something that is costing 576 per kg with something that is costing 176 per kg to create a mixture that costs us 376 per kg. So here it's time for alligation mixture, everybody, and thankfully the difference is very simple, 200 and 200, that is 1:1. So we have concluded that the final mixture should have coffee and cocoa in the same ratio, 50% 50%, and it was of 10 kg. So answer here is definitely 5 kg. So that is the end of the first method. Now pay attention to the second method. I'm starting the question again. Here is a separator. Question said 16% coffee cost was 240. Second one, 36% coffee, the cost increased. That means increasing coffee actually makes the mixture costlier. The final mixture had a cost of 376. It should have even larger percentage of coffee in it. Let's find the gaps. It increased by 20%. So the cost also increased by 80. This is also increasing by 56. Can you see a ratio of 10:7 here between 80 and 56? That is the ratio that you should target here as well. If this was 10, you know what is going to be a 7. So 10 is 20, 7 should be 14%. This is telling us that you should increase this 36% by 14%. So 50%, that is what you were targeting. 50% of 10 is 5 kg. That's a super shortcut, everybody. The question is, Ankita is twice as efficient as Bipin, while Bipin is twice as efficient as Chandan. All three of them start together. Bipin leaves the job after 20 days. If the job got completed in 60 days, the number of days needed by Chandan to complete the job alone is. Let's start with the first statement. Ankita twice efficient as Bipin, Bipin twice efficient as Chandan. So it's time to assume some efficiency or work per day rates. We have three characters A, B and C. Ankita double, then Bipin, Bipin double, then Chandan. So I'll start with Chandan. Chandan, I'm assuming that Chandan does 1 unit of work in a day. Then Bipin must be doing 2 units of work in a day. And Ankita, who is twice as efficient as Bipin is, should be doing 4 units of work per day. So these are work per day. Further, they are saying that all three of them start together on a job. Bipin leaves the job after 20 days. Now, Bipin is somebody who does 2 units of work in a day. Bipin worked for 20 days. So before leaving, Bipin would have finished 2 into 20. 40 units of work out of the entire work. The job got completed in 60 days. That means both A and C, when added, they actually do 5 units of work every day. And they work for whole 60 days from start to end. So A and C together as a team would have finished 300 units of work. In this way, they finished the entire work. So now we know that 340 was the total work to be done. This was the total work. Now let's read the question. the number of days needed by Chandan to complete the job alone. The work is worth 340 units, and Chandan is somebody who does 1 unit of work in a day. So, the number of days required by Chandan should be total work, that is 340, divided by Chandan's rate of work, that is 1. So, 340 days should be the answer to this question. The question here is the set of all real values of x for which x square minus modulus x plus 9 plus x greater than 0. So there are two different approaches. First is proper approach, in which we'll find the exact answer on our own, and then there would be a second approach, that is for the actual testing time. In ideally in a CAT scenario, you might like to use this method just to get the right option. So starting with the first method, everybody, proper method. Let's understand the basics first. Module x is always equal to x if x is positive, n is equal to minus x if x turns out to be negative. We here have x plus 9 in the modulus. So I can write the same like this. X plus 9 will become x plus 9 if I assume that x plus 9 is a positive number, and it will become minus x minus 9 if x plus 9 is something negative. Let's simplify this. This basically wants us to take x greater than minus 9, and this wants us to take x less than minus 9. So we'll divide the entire discussion in two parts: x more than minus 9, x less than minus 9, and we'll have to take care of minus 9 itself as well. So if x is greater than minus 9, then the modulus will have literally no impact on the solution. I'll simply replace the modulus by x plus 9, and the equation should look like this. This gives us x square minus 9 greater than 0, x square greater than 9, x greater than 3, x less than minus 3. Now please understand, this particular scenario was created with one assumption: your x is more than minus 9. So although this ends with this, we should write it as 3 to infinity union minus 3 to minus 9. Nothing more than that, because the first case only talked about the x which are more than minus 9. So we cannot accept any x less than minus 9, even if the solution allows it to be. That's the end of first case, everybody. Second case, x less than minus 9, second case. In this case, the modulus x plus 9 will be replaced by minus x minus 9, and there is a minus waiting outside. So it should become x square plus x plus 9 plus x greater than 0, ultimately producing x square plus 2x plus 9 greater than 0. Now this is interesting. We know x square plus 2x plus 1 is a perfect square. X square plus 2x plus 1 is a perfect square of x plus 1. That means this is actually x plus 1 whole square plus 8. This has to be positive in case of any x. So for all the values here, x less than minus 9, the situation here is actually become a success. It is happening there. That means I'll have to invite all the numbers less than 9. So minus 9 to minus infinity becomes the answer here. So when I add this with this, I have got the entire range except for minus 9, because we missed minus 9. We consider case greater than minus 9. We consider case of x less than minus 9. We missed the case of x is equal to minus 9. We'll have to check it manually. You put x is equal to minus 9 in the actual question. If it turns out to be greater than 0, which is the case, then it is also part of the family. So with that, by merging all the three answers, which are this, this and this, we get the first option as the answer. Now, that is the proper method, everybody. In actual exam, you might like to avoid doing this detailed solution. You should know that there are 4 options. And you can see that option 2, 3 and 4, all of them actually exclude -9, and the first one actually includes -9. If you just put -9 in the actual equation just to check whether it should be part of the answer or not, that -9 survives successfully. That means we don't know the answer, but answer has to have a -9 in it, something that option 2, option 3, option 4 are not allowing. This was a shortcut that would be very useful in actual CAT, even if you know how to solve this entire question like this. So that's a shortcut, everybody. This question has an hexagon. A, B, C, D, E, F is a regular hexagon. P and Q are the midpoints of A, B and C, D. Then we have to create a trapezium PBCQ, and we have to find its area against the area of actual whole hexagon, that is ABCDEF. First of all, let's draw a very decent looking regular hexagon ABCDEF. In examination, we do not have any great tools, so I'm trying to draw the figure here by hands only. ABCDEF, the points may look like this. Now, the instruction P and Q are the midpoints of AB and CD. So this can be point P, this can be point Q. Let me connect them so that I can see the trapezium PBCQ. It's quite visible now. We have to find ratio of the area of PBCQ in comparison to whole hexagon. There are multiple ways of dealing with this particular question. However, I found a particular way very interesting. For that, you should know two things. First, I hope you know that any regular hexagon can be divided in 6 equilateral triangles with the same length of the side. So you can see 6 equilateral triangles. Each of them has a length of side which is equal to the length of regular hexagon. Second thing that if you know will help us a lot. In any triangle, if you connect midpoints of all the 3 sides, you end up dividing the original triangle in 4 congruent triangles. Congruent triangles, that means their areas are equal. I'll do the same with triangle BC and let me call it O. Triangle BCO, I'm trying to do the same. Midpoint, because if this was midpoint and this was also a midpoint only, then we can assume that it will continue through the rest of the figure as well. So this point is also midpoint, this point is also midpoint. Let me add one more midpoint. So I can see that 1, 2, 3, 4. These are the 4 parts of triangle OBC. Now triangle OBC has 4 parts. That means the entire hexagon should have 4 into 6, 24 such parts, 24 such small triangles. Our trapezium PBCQ had actually 1, 2, 3, 4 and 5 such parts. So out of 24 parts in which the main hexagon was divided, trapezium PBCQ covered 5 parts. So 5 out of 24, option number 4 becomes your answer. The question here talks about the ratio of expenditure and incomes. The ratio of expenditure of Lakshmi and Meenakshi is 2:3. Whereas, very carefully, the ratio of income of Lakshmi to expenditure of Meenakshi is 6:7. If excess income over expenditure is saved by Lakshmi and Meenakshi, and the ratio of savings is 4:9, then the ratio of their incomes is. Alright, so let me first of all create a table to capture income, expenditure, savings of Lakshmi and Meenakshi. The table might look like this. Lakshmi, Meenakshi. I start with income. Then expenditure. After subtraction, we'll get the savings. Alright, now let me follow every detail in order. Ratio of expenditure of Lakshmi and Meenakshi is 2:3. So here are the expenditures. I can say 2x and 3x here. These are the expenditure of Lakshmi and Meenakshi. Ratio of income of Lakshmi to expenditure of Meenakshi. Once again, this is the expenditure of Meenakshi. They are in the ratio 6:7. So I can write 6y and 7y. Now, the same item, that is expenditure of Meenakshi, is 3x as well as 7y. So let me take 3x is equal to 7y is equal to something that is a multiple of 3 and 7 both. Yes, you guessed it right. I'll take 21. So I am taking this as 21. That's an assumed value here. That means my x becomes 7 and my y becomes 3. Now let me continue with the story once more. We knew the expenditures of both the people here were in the ratio 2:3. So if 21 was the 3 equivalent part, this better be a 14. And similarly, another ratio was 6y:7y, where y is equal to 3. This should be 18. Alright. Now let me do the subtraction here. 18 minus 14 produces the 4. And further, we know that the excess income, which is obviously savings, the savings were in the ratio 4:9. We are lucky to get a 4 here directly, so I'll be able to write a 9 here straight away. We saved 9 by spending 21. We must be earning 30 at the beginning. That's about Meenakshi. The question here was, find the ratio of the incomes. Incomes now in my discussion are 18:30. So answer will be 3:5. The last option is correct. The question here says, AN is the nth term of a decreasing infinite GP. A1, A2, A3's summation is 52 and A1, A2 plus A2, A3 plus A3, A1 is 624. The question wants us to find summation of this entire GP. I'll start in a very traditional way. The first term can be assumed as A. The standard ratio can be taken as R. That should make A2 A into R and A3 A into R square. So let me put it in the language of A and R only. A1, you are A to me. A2, you are A into R, and A3, you are AR square. Summation of all of them is 52. I can simplify this by taking A common. It should read like this. Second equation. It was A1, A2 plus A2, A3 plus A3, A1 is equal to 624. A1 is A and A2 is A into R. So I should write A square into R plus A2 is A into R, A3 is AR square. So I should write A square R cube plus A3 is AR square and A1 is A. So I should write A square R square is equal to 624. Let's simplify this. I can take A square common, I can take R common. So I'm left with 1 plus R square plus R is equal to 624. Now, if you see carefully, we have a lot in common between equation 1 and equation 2. First of all, the entire bracket is common. I can also take out 1a as common from here. That means equation 2 can be rewritten as 1r is pending, 1a is pending. So I can write a and r. Everything else can be replaced by simple 52 on the left hand side. Right hand side is anyway 624. So AR can be rewritten as 624 divided by 52, which turns out to be 12. So with this, we have got the middle term out of the three numbers A1, A2 and A3. Your A2 is 12. That is what we have understood. Now let me bring A1 plus A2 plus A3 one more time in the discussion. A2 is in reality 12. Now we know that. So let me write 12 here. A1 into R was 12. So A1 should be 12 divided by R. A2 into R was A3. So I should write R into 12 to replace A3. 52. Taking 12 common, I can write 1 upon R plus 1 plus R is equal to 52. Now this is going to create a quadratic equation. After simplification, you will be able to find 3R square minus 10R plus 3 is equal to 0. It has two different roots. One is 1 by 3, another 1 is 3. Since this is going to be a decreasing GP, I'll go with this. R is equal to 1 by 3. Every next number is 1/3 of the previous one. So if the middle one was 12, the previous one should be 3 times of it, that is 36, and the next one should be 1/3 of 12, that is 4. Summation of which is indeed 52. Now to get the final answer, I can say summation of infinite GP is always A divided by 1 minus R. A is the first term which we now know is 36. R is 1 by 3. This will get you the answer 54, option number 3 finally. However, you can reduce the rough work after you find 12 as the middle term. Once you know 12 is the middle term, you can actually avoid the rest of the calculation and rest of the quadratic equation related solving by simply thinking on this line. Summation of 3 numbers is 52. They are very likely going to be natural numbers. So if the middle term is 12, the first term should be probably twice, thrice, 4 times a natural number times of 12 only. So if you just do hit and trial, into 2 will fail, but into 3 will succeed. And how would you know you have succeeded? When you do into 3, you also get 36 and 4 on the other side. So 36, 12, 4, the summation is 52, that's your confirmation. So I strongly recommend that after you find 12 here, you should simply try putting some ratios which can generate natural numbers. And going in the backward direction, doing into 3 will help, which eventually is 1 by 3 ratio going in the forward direction. I hope this helps. Now this is an interesting question. We have these two powers, x square plus 2x minus 3 and x square plus 2x minus 2. Both of them are quite similar with a difference of 1 only. So I'll assume the smaller one as y. By smaller one, I mean x square plus 2x minus 3. That's the smaller one out of both the powers. I am assuming it to be y. So the entire equation can be rewritten as 9 raised to y minus 4 3 raised to, carefully, in comparison to the first power, the second power is actually 1 larger. So I should write y plus 1 here. Plus 27 is equal to 0. That is 9 raised to y minus 4 into 3 raised to 1 into 3 raised to y. Plus 27 is equal to 0. 3 raised to y, 9 raised to y. This gives us another hint that 9 can be represented in form of 3's as well. So 3 raised to 2y minus 4 3's are 12 into 3 raised to y plus 27 is equal to 0. I'll assume 3 raised to y as k. With that, I can rewrite the given equation as a normal quadratic k square minus 12k plus 27 is equal to 0. With that, k will be either 3 or 9. Let's put the value of k back. K was anyway 3 raised to y. So 3 raised to y is equal to 3 or 3 raised to y is equal to 9. Better we write them as 3's powers. So this gives us y is equal to either 1 or y is equal to 2. Now we remember y was in reality x square plus 2x minus 3, the first step of this entire solution. Right? Both of them can be further solved to get the values of x. However, the question wants you to find the product of all possible values of x. So we don't want values of x, we just want the product of all the values of x. So the first rectangle can be rewritten as x square plus 2x minus 4 is equal to 0, and the second one can be rewritten as x square plus 2x minus 5 is equal to 0. We can simply go with c by a, that is product of roots for both of them, and that is going to be minus 4 in case of the first one, minus 5 in case of the second one, the product of which is going to be the answer to our whole question. 20. Option number 3 is correct. If m and n are integers such that product of m plus 2n and 2m plus n is 27, then the maximum possible value of 2m minus 3n is. The first step here should be, we have to split 27 into two parts. Each of them should be an integer value. So 27 can be splitted into 1 into 27 or 27 into 1. Why should we stick to only positive numbers only? It can be an outcome of minus 1 and minus 27 or minus 27 minus 1 as well. 1 into 27 was one way of splitting 27. We have another ways as well. So we can have a 3, 9. We can have a 9, 3. We can have a minus 3, minus 9. And lastly, minus 9 and minus 3. So these are the ways in which we can split 27 in two parts while ensuring that both the parts are integer, because m and n are integers. So both m plus 2n and 2m plus n have to be integers only. Ideally, we have to solve these 8 pairs individually just to ensure that we get integer m and integer n. But then let's use some common sense. For the first 4 here, which are the ones made of 1 and 27, we can actually rule them out by simply observing one particular situation. That is, when you have m plus 2n, let's say 1, and 2m plus n, let's say 27, I'm picking up the first pair. The summation here is 3m plus 3n is equal to 28. Please observe that left hand side is a clear multiple of 3, whereas the right hand side is not a multiple of 3. That means we cannot have both m and n integer together. This rules out the entire first 4 rows. None of them can actually give us both m and n integers. So we don't need to work on the first 4 rows, luckily. But we are not so lucky with the remaining ones. Remaining 4, which are basically made of 3s and 9s, when you add them, they are indeed producing something that is a multiple of 3. That means we have a case to go deeper into each of them. So let me take up the first pair, that is m plus 2n is 3 and 2m plus n is 9. We'll solve them typically the way we typically solve linear equation. We'll get the values m is equal to 5 and n is equal to minus 1. I'll write the same here as well. I'll put the values of m and n in 2m minus 3n to get the final answer. That here looks like 13. We'll do the same with remaining pairs 9, 3, minus 9 and minus 9, minus 3 as well. I'll simply put the values here, which you will eventually get after solving those linear equations. In real exam, this will actually consume a lot of time. We have to take care of the plus and minus as well. We are looking for the largest value that we can see in the place of 2m minus 3n. The last one, 17, is the largest value, which is the answer to this question. Overall, I would want to say that this is actually a lengthy question. In real examination, you might not like to give this particular question a high priority. The average number of copies of a book sold per day by a shopkeeper is 60 in the initial 7 days, but 63 in the initial 8 days. On the 9th day, she sells 11 copies less than the 8th day. The average number of copies sold per day from 2nd day to 9th day becomes 66, and we have to find the number of copies sold on the 1st day. So I'll try to explain this question using the drawing approach. On the 1st day, the person sold 60 books. Assume these are 60 books stacked over one another. 60 more, 60 more, 60 more. 5th time, 6th time, and this is the 7th time. Each of them is a collection of 60 books. That's the one way of interpreting the average being 60. Now, second statement says that when you include the 8th day, the average increases to 63. That means it's kind of adding 3 more books here, 3 more books here, 3 more books on the top of every day out of the first 7 days. And obviously on the 8th day, you have your 60 plus 3, 3, 3. That means the 8th day brought everything extra. That includes 160 and those 3, not 7 but 8 times. That's how you get number of books sold on the 8th day. That's basically the old average plus change in average into number of participants, which is 8 days in this case. So on the 8th day, person sold 84 books. That is step number 1. Now, she sells 11 copies less on the 9th day. That means on the 9th day, now we know the number of copies sold will be 84 minus 11. That's going to be 73. On the 9th day, she has sold 73 books. Finally, the main question. Question wants us to find the number of books sold on the first day. We have this one more information. Average of first 8 days was 63, but average of last 8 days, that is 2nd to 9th, is actually 66. First to 8, 2nd to 9, you have almost all the days common except for first and last. So the entire difference in average that you are able to see is actually created by the personal difference of the first day and the last day. The difference in average here is 66 minus 63 is equal to 3. 3 is the difference in average. 3 is the difference in average. And how do you find average? Average is always summation divided by number of numbers. We have 8 numbers in any of the given first 8 or last 8 numbers. So if the average changed by 3 and the number of numbers were 8, then we can say the change in summation is 3 into 8, 24. That's a personal difference between first and last. We know that when we counted the average of second to last, the average was higher. That means the last one is actually larger than the first one with a difference of 24. 9th day had 73 books. So the first day should have 73 minus 24 is equal to 49 books. That's how you can solve this question almost orally. An item with cost price of rupees 1650 is sold at a certain discount on a fixed marked price to earn a profit of 20% on the cost price. If the discount was double, the profit would have been rupees 110. The rate of discount in percentage at which the profit percentage would be equal to the rate of discount is nearest to. So this is a question of CP, SP and MP. I would like to start with a scale where MP is right at the top, then after some gap SP is there, and then after some more gap CP is there at the bottom. Here is a scale. CP is at the bottom, MP at the tops, SP somewhere in between. The question clearly starts with CP is equal to 1650. It also says that the profit percentage is 20%. So I should be able to write SP is equal to CP into 1.20. CP was 1650. Multiplying it by 1.20 will produce 1980. With that, we have found our SP 1980. The question further says that if the discount was doubled, so there was a discount. I can see a discount of, let's say, X rupees here. They want us to make it double. Instead of X rupees, the discount should be X more rupees. So let this be the additional fall of X rupees. Question says that there is still profit of rupees 110. So this gap here is actually 110. Now the real gap between 1980 and 1650 was 330, out of which 110 was captured here. So X should be the remaining part, that is 220. With that, we have found our value of X here. The original discount was of X rupees, that is now 220. When you add 220 to 1980, you will get the MP as 2200. Let me put MP and CP separately here just to show the requirement of final question. CP was 1650 and MP is now available as 2200. The question wants us to find that percentage which when X as a discount percentage, let's say Y percentage, produces an SP which can be found by adding the same Y percentage in the CP. So the maths will go like this: 2200 when reduced by Y percentage is equal to 1650 when increased by Y percentage. This is going to take some time to solve it. Y comes out to be 14, 2 by 7 percentage in reality. You don't need to find it accurately. The question anyway wanted us to find the approximate percentage. So nearest to 14 is the answer that you should mark. Suppose A, B, C are three distinct natural numbers such that 3AC is equal to 8 times A plus B. Then the smallest possible value of 3A plus 2B plus C is. To be able to find such values of A, B and C which can minimize 3A plus 2B plus C, we have to find some combinations of A, B, C which actually can satisfy the given relationship, that is 3AC is equal to 8 times A plus B. There are multiple ways of going forward. I'll choose one way in which I'll try to keep A as a separate entity on the left hand side. Everything else would be on the right hand side. To be able to do that, I'll start with the only relationship that we have. 3AC is equal to 8 times A plus B. That is 3AC is equal to 8A plus 8B. I'll bring 8A on the left hand side. I'll take A common. With that, we get A is equal to 8B divided by 3C minus 8. Right. Now, we'll put different values of A, B and C and we'll check whether they work or not. But that is not very efficient thing to do. Let's use common sense. First, common sense. We have to minimize 3A plus 2B plus C. If we wish to see 3A plus 2B plus C minimized, it's common sense to say that very likely small values of A, B and C will do the justice. So we are not going to deal with large values of A, B, C. Second, 3C minus 8. It's right there in the denominator. It has to be a positive number. That means 3C minus 8 should be positive. You can put some values and can understand C has to be greater than or equal to 3. So let me try with C is equal to 3. If I put C is equal to 3 in this main relationship that we have here, 3C minus 8 becomes 1. And if denominator is 1, I would want the numerator to be 8 only by keeping B is equal to 1, the smallest possible natural number. In that case, A will be 8 divided by 1, which is 8. With this, we have got first set of values of A, B and C which can actually satisfy the main relationship, that is 3AC is equal to 8 times A plus B. What is the value of 3A plus 2B plus C in this case? If you check, it is actually 3 times A, which looks like a pretty large value, 24, plus 2B, that is 2, plus C, that is going to be 24, plus 2 plus 3 is equal to 29. Now the next value, we can try putting C is equal to 4 as well. If we put C is equal to 4, then 3C minus 8 will be 4. 8B divided by 4 has to be an integer, that is 2B. So to make 2B an integer, B has to be 1, A has to be 2 if we wish to keep everything as small as possible. Once again, we'll find 3A plus 2B plus C. That will be 6 plus 2 plus 4. That is 12. 12 looks like a better answer. Now we should try putting 5, 6, 7, 8, 9. But wait, why should we entertain all the values? 5 when put in place of C, that would create 15 minus 8, 7 as the value of 3C minus 8. Now please understand, 7 as a denominator is not a good denominator. To be able to create an integer A, B has to be at least 7. Now these are large values. Just see the benchmark that has been set. We have already got a 12, a fairly small number, with A's value 2, 1 as the value of B, and 4 as the value of C. We can't possibly get a smaller value through values as high as 7 and 5. So let's stop the discussion there. If I put C is equal to 6, I'm getting 10 here, which is again going to create something large value here. 7, 21 minus 8, again a large value, not discussing anymore. 8 is 24 minus 8, 16. 16 in the denominator can be created by putting B is equal to 2. That will produce A is equal to 1. And it's actually good to keep A 1 because A has the highest weightage 3 times. So this looks like worth considering. Let me check 3A plus 2B plus C in this case. That looks like 3 plus 4 plus 8. That is 15. Not bad, but still not the smallest one. The remaining values of C, that is after 8, cannot produce something that is as small as 12, something that we found in the second row. So the minimum possible value for 3A plus 2B plus C is going to be 12. Fx is equal to x divided by 2x minus 1. Gx is equal to x divided by x minus 1. Then the domain of the function hx, which is equal to f of g of x plus g of f of x, is all real numbers except we have options. We'll use common sense first. A denominator cannot be allowed to be 0. So 2x minus 1, you are denominator in case of fx, you cannot be 0. Similarly, x minus 1, you are denominator in case of gx, you cannot be 0. That means x cannot be 1 by 2, x cannot be 1. We have got this much of clarity. And we see 1 by 2 and 1 everywhere. Now we have to find one more exception which can actually help us find the right option. Let's proceed. We anyway had to find f of g of x and g of f of x to be able to find hx. So let's find f of g of x first. If fx was x divided by 2x minus 1, then f of gx should be x replaced by gx everywhere, divided by twice of gx minus 1. Now we can put the value of gx in place of gx to get this. We have to further simplify this. That should be 2x minus x plus 1, and that finally should be x plus 1. So this is going to be the f of g of x, which has x plus 1 in the denominator. This further tells us that the denominator x plus 1 cannot be 0. So x cannot be minus 1. With that, we have got our third exception, and option number 3 is the right option. Two tangents drawn from point P touch circle with center O. Center O, point P, touch the circle with center O at points Q and R. If I draw this, they are going to be radiuses, creating a right angle each. Point A and B lie on PQ and PR respectively, such that AB is also tangent to the same circle. So this can be A and B. As you can see, it touches the circle, hence AB can be called a tangent. Lastly, we have the measurement of angle AOB as well. AOB is 50 degree. Angle AOB is 50 degree. And the question wants us to find angle APB. Angle APB is the question. Now, there is a theory of the tangents that I want you to understand. For any circle, a point outside of the circle creates two equal tangents. Also, a fact that the line connecting center with that particular point acts as an angle bisector. So if this is x degree, this has to be x degree. This is because of the fact that both the triangles that now you are able to see are actually congruent. You are actually looking at a kite. Alright, how would we use the same in our question? Connect center with the touch point of line segment AB with the circle. So let me declare this C for time being. Now can you see that point A is acting as that point outside of the circle, which is creating two tangents, QA and AC. And because of that, this and this should be equal, theta and theta. Quite similarly, point B also acts as a point outside of the circle, which is creating two equal tangents. This and this angle should be equal. In other words, I am trying to say that OA is an angle bisector, OB is also an angle bisector. We knew AOB was 50. If you see carefully, angle AOB was actually theta plus phi. Now, see angle QOR. That is 2 theta plus 2 phi. That is twice of theta plus phi. That is 100 degree, because we knew theta plus phi is 50. I want you to focus on the quadrilateral OQPR. Quadrilateral OQPR has 4 angles, 4 sides. So summation of all interior angles should be 360. We know angle Q is 90. We know angle R is also of 90 degree. Angle P is our question. Angle O now is available as 100. Summation of all of them has to be 360. After doing a subtraction, you will find that angle P, or better I say angle APB, is going to be 80 degree. The question here says, a certain amount of money was divided among Pinu, Meena, Rinu and Seema. Pinu received 20% of the total amount, Meena received 40% of the remaining amount. If Seema received 20% less than Pinu, the ratio of the amounts received by Pinu and Rinu is. So we have 4 characters. Let's call them P, M, R and S. A quick look at all the percentages. We have 20, 40 and 20 percentage. So I want to assume that assuming the total money as 100 would be a wise decision. So I'm assuming 100 to be the total amount. Pinu received 20% of the total amount. So Pinu, you have 20 rupees. Meena received 40% of the remaining amount. 100 minus 20 is 80. 40% of 80 is actually 32. With that, 52 rupees have been distributed. We have 48 rupees with us. If Seema received 20% less than Pinu, Pinu who received 20, 20% of 20 would be 4. Let's subtract it from 20, that is 16. That is what Seema has. Seema has 16, that is 20% less than what Pinu has. We discussed that this is 48. R plus S is 48. That makes R is equal to remaining 32. Alright, now the question. The ratio of amounts received by Pinu and Rinu. Question wants us to find the ratio between this and this, 20 and 32. It is 5:8, option number 1. The question here is, if A, B, C, D are integers such that their summation is 46, then the minimum possible value of A minus B whole square plus A minus C whole square plus A minus D whole square is. Now, these 3 terms are actually perfect squares. So they can't be less than 0. They have to be non-negative. So at least they would be 0. And I'm trying to make all of them 0 together if possible. To make each of them 0, I have to make A minus B 0, A minus C 0, A minus D 0. That means A, B, C, D all should be equal. But we must remember that A, B, C, D are supposed to be integers as well. If they all are equal, the summation must be a multiple of 4, sadly which is not the case. So it's impossible to get 4 equal values of ABCD which are integers as well. That means I can't keep all of them equal. If you cannot keep them equal, you should do the next best. Try to keep them as close as possible. So 46, I cannot divide it into 4 equal parts. I'll try to bring parts as close as possible. That would be 12, 11, 12, 11 in any random order. I can keep this A, B, C and D. You can shuffle them as per your wish. So A, B, C, D, although they are not equal, they are as close as possible. Summation is 46. You can see A minus B is going to be 1 whole square. A minus C is fortunately 0 whole square. And A minus D is again 1 whole square. So answer is 2. Our answer cannot go below 2 in any case. A loan of rupees 1000 is fully repaid by 2 installments of rupees 530 and 594 paid at the end of first and second year respectively. Interest is compounded annually. What is the rate of interest? Alright, so let's borrow 1000 rupees. In first year, the amount would have increased by R percentage. Here the R is going to be the answer. You paid 530 rupees at the end of first year. That means this square bracket represents the amount outstanding at the end of first year. The remaining amount again increased by R percentage, and this here on the screen is the total amount to be paid at the end of the tenure, which actually is 594. Now we have to solve this equation. If we solve, we get the answer, which is possible, but it's very time consuming considering the 40-minute time constraint in the actual CAT paper. So I would recommend you not to solve this, but to put options here. Now when we put options, I recommend you to put all the options in the increasing order first of all, and start with any one of them at the middle. Why so? Now when you start something which is at the middle, let's say if you start with 10, and by chance if it fails, and there is only 1/4 chance that a particular option might succeed. So by chance if it fails, while failing it will let you know whether the number 10 was found little larger than what it should have been or smaller than what it should have been. So basically while failing it will take couple of options with it if you are lucky. I'll start with 10. 10 seems nice. So putting R is equal to 10 here to get 1100 minus 530 when increased by 10 percentage. So I should write 1.10. I'm checking whether this is going to be 594 or not. 1100 minus 530, that is 570 into 1.10, that is 570 plus 57, that is definitely more than 600. So this is greater than 594. 10, you are not my answer. At the same time, 10 turned out to be actually a value larger than the actual answer because it produced something more than 594. So I will reject 11 as well. If 10 was too big, 11 is even larger. So answer is 1 of 8 and 9. Now you put any one of them in the place of R. If it works, that is the answer. If it fails, the other one is the answer. The actual answer is 8. I'll show you why. Put R is equal to 8 in the original equation. That is what we had to do. 1000 when raised by 8 percentage should be 1080 minus 530 raised by again 1.08. If you check carefully, this is actually 594. Perfect for this particular situation. So 8% is your answer. Triangle ABC has point D and E on the sides BC and AC. As you can see in the figure, I have drawn a random triangle ABC. You can see point D lying somewhere on line segment BC and point E lying somewhere on line segment AC. Now, BE and AD intersect at point T. It's time to write T here such that AD is to AT is 4:3 and BE is to BT is 5:4. Further, point F lies on line segment AC such that DF is parallel to BE. As you can see in the figure, I have drawn the same as well. I want you to focus on triangle ADF. In this triangle, line segment TE is parallel to line segment DF, thanks to which I can say AT by AD should be equal to TE by DF. We already know AT by AD is equal to 3 by 4 as mentioned in the main detail here. If I declare TE as 3x, then DF should be equal to 4x. So let this be 3x, this should be 4x. Now it's time to focus on the next ratio. BE is to BT was 5:4. So I can see that TE is actually 3x, but entire BE is actually kind of 5y and BT is 4y. That makes TE a single y. So if I write 12x here, it does the justice. Let's check. BE in this figure is now 15x, whereas BT is 12x, which is perfectly 5:4. So let's focus on the another triangle, triangle BEC. In this triangle, once again you can see DF is parallel to BE, and that's why the ratio of FD to BE must be same as the ratio of CD to entire BC. FD is to BE is now visible as 4x to 15x. That should be the ratio of CD and BC. If CD is, let's say, 4y, then BC is 15y. So I should write BD as equal to 11y. The question wanted us to find BD is to CD. The answer is 11:4. The number of divisors of 2 raised to 6 into 3 raised to 5 into 5 raised to 3 into 7 square, which are of the form 3r plus 1, where r is a non-negative integer, is. So question wants us to find factors of this fairly large number which are of the form 3r plus 1. What is 3r plus 1? The meaning of 3r plus 1 is when that number is divided by 3, it should leave remainder 1. Or in other words, it should be 1 more than the nearest multiple of 3. Basically, the numbers that we are looking for should have two qualities. One, they should be factors of the large number, and they should leave remainder 1 when divided by 3. That means there is no point of including 3⁵ in the discussion, because if it becomes part of the factor of my answer, then the number itself will be a multiple of 3. So we should completely ignore that. We cannot touch it. So the participants here would be the rest of the numbers. 2⁵, 5⁵, 7⁵. 2, 5, 7, none of them is actually multiple of 3. They have a potential to create something that is capable enough to leave a remainder 1 when divided by 3. But not exactly everything will leave a remainder 1 only. They might leave a remainder 2 as well. So we'll have to work with various combinations. We want exactly 1 remainder. Let's focus on 2. 2 when divided by 3 leaves remainder 2. So this is fine as 2⁵. But 5 when divided by 3 leaves remainder 2. So this can be rewritten as 2⁵. 7 when divided by 3 leaves remainder 1. So this can be rewritten as 1⁵. Now 1:2 is basically 1. It's completely harmless. In fact, it is something that we wanted. It is 3r plus 1. 7 when divided by 3 leaves remainder 1. You can check 7 square as well. 7 square, which is 49, when divided by 3 leaves remainder 1. So 7 square, you are perfect. 7 square or any factor of 7 square is welcome. 7 square or any factor like 7⁵1 or including 7:0, everything is actually of the form 3r plus 1. They all are welcome, 1, 2 and 3. However, that is not the case with the powers of 2. Let me play with the powers of 2. 2 raised to 1 is 2, 2 raised to 2 is 4, 2 raised to 3 is 8, 2 raised to 4 is 16. Let's start dividing them by 3 and let's note remainder after dividing the numbers by 3. When I divide 2 by 3, I get remainder 2. When I divide 4 by 3, I get remainder 1. That's a success. When I divide 8 by 3, I again get remainder 2. When I divide 16 by 3, I get remainder 1. That's a success. And this trend of remainders 2, 1, 2, 1, 2, 1 will continue. So here we can observe that all the even powers of 2 are actually generating 1 as a remainder when divided by 3. So 2 raised to 6 and 2 raised to 3, both of them are going to produce some 2's only. We want even number of 2's. Now how can we get even number of 2's? Let's divide this discussion in two parts. 2 raised to 6 can actually supply odd number of 2's and 2 raised to 3 can be asked to supply odd number of 2's. Odd number of 2's plus odd number of 2's, that is even number of 2's. Odd plus odd is even. Or both of them can provide even number of 2's. Let me show you how. 2 raised to 6 can be asked to produce 2 raised to 0 or 2 raised to 2 or 2 raised to 4 or 2 raised to 6. In turn, 2 raised to 3 can give us 2 raised to 0 or 2 raised to 2. Here the powers of 2 are even. Here also the powers of 2 are even only. Now let's focus on odd into odd combination. 2 raised to 6 might give us 2 raised to 1 as a factor or 2 raised to 3 as a factor or 2 raised to 5 as a factor. Similarly, 2 raised to 3 can produce 2 raised to 1 or 2 raised to 3 as a factor. It's time to check how many combinations do we have. These are 4 combinations. These are 2 combinations. 4 2's are 8 combinations of even. Let me write even plus even. We add powers when we multiply numbers. Here there are 3 combinations and 2 combinations. So I should write 3 into 2, 6 combinations. This was actually odd power plus odd power. So there are 14 such combinations which I can create from 2 raised to 6 and 2 raised to 3. For each of these 14 combinations, the powers of 7 are ready in 3 different forms: 7 square, 7 raised to 1, 7 raised to 0. So this 14 should be further multiplied by 3 to get 42 as the final answer. Rita and Sneha can row a boat at 5 km per hour and 6 km per hour in still water. In a river flowing with constant velocity, Sneha takes 48 minutes more to row 14 kilometers upstream than to row the same distance downstream. Let's focus on this much part first. So the difference of time taken between the upstream journey and downstream journey for Sneha was 48 minutes. So let me write it like this: time 1 minus time 2 was equal to 48 minutes. But all the speeds are in the unit kilometer per hour. So better I convert this time into hours instead of minutes. So instead of 48 minutes, I am writing 48 by 60 hours. Now you know time is equal to distance divided by speed. Distance was anyway 14 kilometers while going upstream as well as while coming downstream. While going upstream, the speed would be Sneha's speed, that is 6, and reverse speed, let me assume it as x. So 6 minus x should be the upstream speed, whereas downstream speed should be 6 plus x. 48 by 60 can be simplified as 4 by 5. Now we can solve this equation. It should ideally produce a quadratic equation, but then you can just observe some numbers here. You can put x is equal to 1, 2, 3 just to create something that is similar. For example, I am looking at a denominator 5. How can I create a denominator 5? Probably by putting 1. That is just probably. It might work, might not work, but it is working. So instead of solving this properly using quadratic equation, you might like to give it a try by putting some value. If they make LHS and RHS equal, you got the right answer. Here it is going to be x is equal to 1 kilometer per hour. That's the speed of the river here. It's flowing at a constant velocity. That velocity is 1 kilometer per hour. Now let's focus on Rita. Rita starts from a certain location in the river. So we don't know the location. That means we don't know the distance covered by Rita as well. And returns downstream to the same location. Basically, she goes upstream for distance, let's say d, comes downstream, again the distance d, and she does everything in 100 minutes. So better I write d, that's the distance assumed by us, and that is going to be the answer as well, divided by, let me start with upstream first. So upstream speed of Rita should be Rita's speed minus river speed, which now know is 1, plus distance divided by 5 plus 1, that is the downstream speed, should be equal to 100 minutes. Let me write 100 by 60. So when you solve this, you get d is equal to 4 kilometer. What is that? That is one-way journey. 4 kilometer upstream, 4 kilometer downstream. The question here was total distance in kilometer. That should be 4 plus 4, 8. Log x square base 64 plus log square root of y base 8 plus 3 times log square root of y into z base 512 is equal to 4, where x, y, z are positive real numbers. Then minimum possible value of x plus y plus z is. That is our question. Now if you see carefully, the bases are 64, 8 and 512. All of them are the powers of 8 only. 8 raised to 1, 8 raised to 2, 8 raised to 3. So let's convert all the bases into powers of 8. The first one can be rewritten as log x square base 8 square. The second one itself has a base 8. I'll just write y raised to 1 by 2. Third one is 3 into y raised to 1 by 2, z raised to 1, and 8 raised to 3 will serve as a base, is equal to 4. Now the base 2, the power 2 and the power 3 of the base here will come out. They will come out in the denominator part. So when 2 will come out, it will look like this. Similarly, the second term will be unchanged. It is already ready with base 8. However, the third term has 8 raised to 3 in the denominator. 3 will come out in the denominator just to get cancelled out eventually. Right. It's time for simplification. This 1 by 2 will go up here, will get multiplied, will get cancelled. So we'll have a simple log x base 8 here, plus log 1 by 2 base 8 here is anyway waiting, and plus log y raised to 1 by 2 into z raised to 1 with the same base 8 is here. It's time to club all of them. We have the same base 8, 8 and 8 with summation in between. It's our signal to merge them all into a single entity. With the same base 8. This is going to be log x, y, z base 8 is equal to 4. So now we know x, y, z is in reality 8 raised to 4, or I can write 2 raised to 3 whole raised to 4, or 2 raised to 12. Now the main need of the question, which is summation of x plus y plus z, the minimum possible summation. If you want to minimize the summation of x, y, z, you must keep them equal. So if x, y, z, if they all are equal, then each of them is going to be 2 raised to 4, 2 raised to 4 and 2 raised to 4 only. If each of them is 2 raised to 4, that is 16, 16 and 16 only, the minimum summation is going to be 16 plus 16 plus 16, which is 48. So 48 is the final answer to our question. The summation of digits of the number 625 raised to 65 into 128 raised to 36 is. Let's simplify both the numbers. 625 is made of 5s. 5 raised to 4, raised to 65 is the first part. 128 is made of 2's. 2 raised to 7 whole raised to 36. This can be further simplified as 5 raised to 260 into 2 raised to 252. The key number here is 10. A 10 as your factor produces 0 in your number. 2 such 10, 2 such zeros. N number of 10s, n number of zeros. And those zeros in your number will not contribute to the summation of the digits. So let's take out all the 10s that can be created using 5s and 2s. A 10 can be created by 1 5 and 1 2. We can see that we have lesser number of 2s. So we'll be able to create 10 252 times. And after that we'll be left with 5 8 times. So our number is actually 5 raised to 8 into 10 raised to 252. So our number is actually 5 raised to 8. That must be a large number, basically 625 into 625, which is going to be 390625 followed by 252 zeros. Basically we don't need to focus on that. Question wanted us to find summation of digits. So the answer here is going to be the summation of 3, 9, 6, 2 and 5. The answer here is 25.